Scalars and vectors. Scalars and vectors are types of measurements that we use in science. Now we're used to scalars because they measure how much. Measuring how much, that's referred to as a magnitude. Examples of scalars include distance, speed, time, mass, energy, and temperature. Now these are scalars because they don't include a direction. It wouldn't make sense to say that the time is 3 seconds downward or temperature is 30 degrees Celsius to the north. Those just don't make sense to put a direction on. However, vectors are measurements that include a magnitude, which is how much, also with a direction. Examples include displacement, velocity, and acceleration. These are three vectors we've talked about before in this previous unit. Force and momentum, we're going to talk about forces in Unit 3 and 4, and then momentum in Unit 6. Now these all have directions. It makes sense to say acceleration, let's say for example the acceleration due to gravity is 9.8 meters per second squared downward. That makes sense. A force is going to be 3 newtons to the left. Somebody's applying a force to the left. So it makes sense to put a direction with that. Here we have an example of the difference between distance and displacement. Now we've talked about the difference between distance and displacement when we said that something moves 8 meters to the right and then 3 meters to the left and then 5 meters to the right, and then we talked about how the total distance traveled and the displacement are different. Here we have 10 meters to the right, 10 meters down, then 10 meters to the left to get from where we started to where we ended. Now if we looked at the total distance traveled, we would say 10 plus 10 plus 10 gives us a total of 30 meters. But it wouldn't make sense to put a direction on that because we got right, down, and left, 3 different directions, so the direction for the distance just wouldn't make sense. However, if we look at the displacement is 10 meters downward because from start to finish we go down. That gives us a direction. It makes sense to have a direction on that. We can also call it south or negative y direction. It depends on the context of the question. If we're talking about the vertical plane, then we're talking about up, down, left, and right. If we're talking about a horizontal plane, like in the middle of a field or forest or something like that, we would say north, south, east, or west. Or if we don't know the context of the problem, we don't really know what it's talking about, then we can refer to the xy coordinate system like the positive x direction or the negative y direction here. Vectors are represented with pictures. We use arrows and draw those to represent the vectors, and the length of the arrow refers to the magnitude of the vector, meaning how much, and then the angle refers to the direction. So here we have north, south, east, and west, and then we have our vector, which is a magnitude of 5 meters and an angle of 30 degrees. Now if I had another vector that was 10 meters, I would expect that vector to be twice as long because the length of the vector represents the magnitude of the vector. Now this 30 degrees, we have to be more specific than just 30 degrees because we could have 30 degrees over here or we could have 30 degrees down here, so we have to identify exactly which 30-degree angle we're talking about. And we do that by looking at this quadrant right here. We're in the northeast quadrant. So we have to identify our vector with respect to things that we already know, directions we already know. We know the east direction and we know the north direction. So if I started east and I were to identify where is my vector with respect to east, I would say my vector is to the north of the east direction. I could also say that from north my vector is to the east of north. Now which one do I choose? Well, if I talk about east of north, then I would need this angle over here, but if I talk about north of east, then I would use this angle right here. So we say the displacement is going to be 5 meters at 30 degrees north of east. We could identify this angle over here. I mean, that's pretty simple. 90 minus 30 gives me a 60-degree angle here. So we could say our displacement is 5 meters at 60 degrees east of north, and it would identify the exact same direction. So here we have another vector. It's going to be 15 meters per second, and our angle this time is 15 degrees. So this angle right here, if we look at our vector, we got south and west. We're in the southwest quadrant here. If we start from south, because that's where our angle is, we would say our vector is to the west of south. So the velocity is going to be 15 meters per second at 15 degrees west of south. We could also identify the vector as being south of west, but we'd have to use this angle over here, so it'd be 75 degrees south of west. You may run into a problem with these, and you could do a problem and your neighbor beside you could do a problem and you get two different angles. Sometimes the reason you get two different angles is because one person found this angle over here, south of west, and the other person found west of south. So if you take your two angles and you add them up and they equal 90 degrees, then probability is that you've done it right. You just have the complements of each angle.